Okay, on this activity, we were asked to classify whether a polynomial was even or odd. And the best way of doing this, or neither, and the best way to prove it and show your work is to plug in negative x into these values. So we're going to solve for f at negative x. And so I did a already. I'm just going to clean this up a little bit. So this is the tricky part here, because you have to do negative x all squared. So it's negative x times negative x, which gives you the positive x squared. And then you do negative 2 times negative x, which gives you positive 2x. Now, I wrote here, if it's even, we know that when we plug in f at negative x, it has to equal itself again. That's for even. And for odd, when we plug in f at negative x, we get the negative version of f at x. Meaning, we can common factor out a negative number here. So if we did that on this one here, we'd have negative, and then we'd have negative x squared minus 2x. Well, it's not saying negative times our original function, which didn't happen here. So that's why this would be a neither, because this is not negative times this original function, nor is it itself. If you look at b, we plug in f at negative x, we get 3 times negative x to the power 5 minus 4 times negative x. When we do this one, you will get negative 3x to the power 5, because negative x to the power 5 is going to be negative x to the power 5. The negative multiplied by itself 5 times becomes negative again. And this is going to be positive 4x. Now this doesn't look like the original function as well, but what we can do here is we factor out a negative, we get here our original function again. So this is equal to the negative version of our original function, so this would be odd. And that's how you do it for these ones. You plug in those values, and when you either get you can factor out a negative one from there and get back the original function, it's odd. If it goes back to the original, you get an even function. As I'm saying that, I did C here, and if you look, we get back to our original function. Oh, nice. That means this one is even. So that's the big thing you want to do. Don't worry about this one, because we're not dealing with that right now. We aren't even actually dealing with the rationals at the moment, but it's just good practice to plug in negative x and see what happens with those.